Hey guys, it's Yuvan, and we're going to be doing number 36. Alright, here we go. The sides of an equilateral triangle are increasing at a rate of 10 centimeters per minute. At what rate is the area of the triangle increasing when the sides are 30 centimeters long? Alright, so first of all, so we have the side are 30, so let's just say x is 30, right? The derivative of x is 10 centimeters right there. Alright, and we're trying to find how much the area is increasing by. So first, let's draw a picture of what it should look like. 30, 30, 30, right? All right. And so let's use the formula. To find derivative of area, we need area, right? So let's use the formula half times base times height, right? This area. What do we not have here? So for this, we're going to need this, and we're going to need height. Right? What's height? We're also going to need to know the derivative of height, or how much is height increasing by, right? Yeah. So that's what we need to make the formula. So, or that's all we need to make the formula of the derivative of this. And that would look like this. So the derivative of this would look like half 0.5 times h times dB over dt, right? Because that's product rule, right? Plus 0.5 times b times dh over dt. And that's just product rule. Is equal to dA over dt. You get that? You know what I mean? Because derivative of b is 1 times h, because h stays the same, times the derivative of our derivative value b, okay? Just in case you didn't know. Yeah, it's the product rule. Y'all should know this. All right. So, all right. All right, so let's get finding. So let's find h. How do we find h? So first of all, let's just use the formula half times base times height, all right? Or let's use Pythagorean theorem. My bad, sorry. So let's just say, for example, we're gonna cut this in half, call this h, this is 30, and this is 15. And we're gonna use the Pythagorean theorem, right? So let's just say 15 squared plus h squared is equal to 30 squared. Do it. 330 squared is 900. 15 squared is 225 is plus h squared. You do the math, blah, 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 and that gives you h is approximately 25.981. All right, so let's add that to our list. 25.981. All right, now I have to find the derivative of height. How do you do that? Well, let's just find the derivative of this. All right, so let's go. Let's just call 15a, a height is b, and 30 c, all right? So a squared plus b squared is equal to c squared. Now let's go, let's go derivative of it. It gives you 2a times d of 15, d of x, or it's half of x, right? 2a times, all right, let's just write it down first, my bad. D of a over dt plus 2b dB over dt is equal to 2c dc over dt. All right, so we have this. Now let's do that. All right, let's start plugging in. 15 is a, right? So 15 times 2 here, 15 times 2 is 30. So 30 times dA over dt. 15, what's the derivative of this? Well, derivative of 30, right? Let's just say this. The derivative of 30 is 10, right? The derivative of 30 is 10. And since 15 is half of 30, our derivative should be half of 15, or half of 10. You know what I mean? It's like the similar shapes thing we learned. So because 30 divided by 15 is equal to 2, this should also be 10 over x, it should be 2. So basically, yeah, our derivative for base of 15 of this triangle should be 5, half of our original derivative for the entire side. All right, so times 5 plus 2 times b. b is our height, 2 times our height, 2 times 25.981. I'll do that right here. 25.981 times 2. 51.962 times db over dt. What is height increasing by? We don't know. I'll just write height here. Is equal to 2c. 2 times length, 2 times side length is 60 times the derivative of it, 10. All right, so now let's start plugging in. It's 150 plus 51.962 times dh over dt equal to 600. Do that, move it over. You get 450 over 51.962 is equal to dh over dt. All right, and that turns into 450 divided by 51.962. It's around 8.66. So we can go over here. We can go over here, right? Go over here and type in 8.66. Nice. So we're almost done. Now all we have to do is plug in. Now let's go back to our function that we were using, right? This one right here. And let's just plug everything in. So I can't, oh yeah. So here we go. I'm just gonna copy this and then move it down here. All right, 0.5 times height. Height is 25.982. 25.981, my bad, divided by 2 gives us 12.991 times derivative of a side, or derivative of height, which gives us, or no, I'm sorry, derivative of the side length, which is 10, plus 0.5 times base, 15, times the derivative of height, 8.66, is equal to derivative of area. All right, let's do it. That's 129.91 plus 15 times 8.66. 129.9 is equal to dA over dt. You add them together, 129.91 plus 129.9. That gives us 259.81 is equal to dA over dt. Yeah. That's our answer right there. So, and also, this is also, I didn't know this, but this also should be, or it also equals 150 times square root of 3. That's what it says in the book. And they're about the same, or they are the same number. All right, and so let's finally write our answer down. So we should write our answer similar to what the question says. The rate that the area of the triangle is increasing at is 259.81 cm squared over minute. Boom. That is your answer. All right. Thank you.